This is a note on solving exponential equations. It's brought to you by Energize Math. Please visit energizemath.com at the end of this lesson to download this note. Exponential equations, we're going to break it up in two parts. The first one is when you're going to have common base. You can do this without using a calculator. So if you have, like, for example, 3 to the exponent x equals 27, you want to find what your exponent is. Try to get both sides so they have the same base. So I have 3 to the x. Now 27 is a power of 3. It is 3 cubed. Once you have the same base on either side, you can cancel your base out and simply be left with your exponents, which would be x, and then you'd have 3 on the other side, in which case would be your answer. Sometimes you have to think a little bit harder about what the common base would be. Here, for example, I have 2 to the x equals 1 over 8. Okay, now 1 over 8 can be expressed as an exponent of 2 because 8 is 2 to the power of 3. So this is really 2x equals 1 over 2 to the power of 3. Which, using my negative exponent rules, that is actually 2 to the x equaling 2 to the negative 3. And then I have a common base on either side. I can cancel it out and I'll be left with just my exponents. X equals negative 3. For the third example, here I have a multiplier in front. I need to get rid of that first before I can move on. So I'm going to divide it over to the other side, kind of get rid of it. So I'll be 5 to the 2x plus 4 equals, and I'll divide, so I'll be dividing by 4 because it's multiplying on that side. 100 divided by 4 is simply 25. Now 5 and 25 can be expressed as the same base. 25 is 5 squared, so I have 5 to the 2x plus 4 equals 5 squared. I have the same base, so I can cancel them out, and I'll be left with simply 2x plus 4 equals 2, which is my exponents. And then I can solve this equation. So 2x equals 2 subtract 4, 2x equals negative 2, and x equals negative 1 as an answer. Okay, so that's what you can do. If you can get them both as the same base, you can cancel out your common base. And you can do all that without a calculator. What happens if you cannot have the same base? You do not have the same base. So there's no way expressing 37 as a power of 3. So in this case, what I'm going to do is I'm going to use logarithms. And I want to log both sides. Okay. Now one of the logarithm rules is when you have an exponent you can bring it down in front. So I'm going to have x log 3 equals log 37. Then I'm going to treat this log 3, it is just a number. I'm going to divide it over to the other side, like no different than you did before, to get x by itself. So x equals log 37 divided by log 3. I'm using log base 10 because that's what most calculators will allow me to use. And then you can put that into your calculator. So you would have, where is log? You'd have log 37 equals, and then you divide by, you'd have log 3, hit equals again, and you get an answer of 3.29. And that is your answer. X equals 3.29. So you can just simply put this in your calculator and that will get you your answer. Okay, so logarithms is the key when you do not have a common base. Again, in this case, I have base 7, but I have this 5 multiplying in front. I need to divide it over to the other side. So I'm going to divide both sides by 5, and I'll be left with 7x equals, now 135 divided by 5 is going to be 27. Now we're going to log both sides, log 7x, because I can't get the same base. And I have log 27. I bring my exponent down front, that is one of the logarithm rules. And I'd have log 27. Divide both sides by the log 7. And you can put that in your calculator at this point. So I'd have log 27 equals divided by, and you'd have log 7, hit equals again, and 1.69 as an answer. X equals 1.69. Okay. Now one of the things you have to do to determine if you can get a common base or not. So it's helpful if you are familiar with some common bases. So let's take power of 2. 2 to the exponent 0 is 1, 2 to the exponent 1 is 2, and you can keep on going. 4, 8, 16, 32, 64, okay, 128. These are all powers of 2. You can also have 1/2, 1/4, 1/8. Those are also powers of 2. Okay, these would have negative exponents. Negative 2, they'd be your negative exponents. Same as common base used is 3. So you'd have 1 for 3 to the exponent of 0, then you have 3, 9, 27, 81, and so on. Okay, same as 5s. And 1, because 5 to the exponent of 0 is 1, then you do 5, 25, 125, 625, so on. 7s often used. Any of kind of the easy ones you need to be aware of. So 1, 7, 49. These are if you can get as common base, or 1 over 49. That is the power of 7 as well. Okay, so if you can kind of recognize some of the simple ones, then you can use it without a calculator. If you can't, then you use logarithms. Uses. So for example, let's say I have a question that says I'm going to invest $10,000 at 5% interest per annum, compounded annually. How long until it reaches $25,000? So that would be the equation 25,000 equals, and I started with my 10,000, and it grew at 5%, which means I have a growth rate of 1.05, and I want to solve for my exponent x. Okay, so this is an exponential equation, no different than what I did before, so I'm going to have to divide by my 10,000, so I'm going to have 25,000 divided by 10,000 equals 1.05. That will give me 2.5 equals 1.05 to the exponent of x. And I can use logarithms on both sides. Log 2.5 equals log 1.05 to the exponent of x. Bring my exponent down in front. X log 1.05 equals log 2.5. Divide my logarithm over to the other side. Log 2.5 divided by log 1.05, and that will equal x. And I can put that into my calculator at this point. And I could not get a common base, so I'm going to use logarithms. Log 2.5 divided by log 2.5 equals divided by log 1.05 equals, and I end up getting 18.78. It's equal to 18.78, and in this case it would be years. 18.78 years is how long it would take $10,000 invested at 5% compound annually to reach $25,000. This is solving exponential equations, brought to you by Energized Math. Please visit energizedmath.com to download this note. Thank you very much.